In the last video, we talked about being able to find the areas of sectors of circles and the lengths of arcs of circles, like part of the circumference and just part of the area of a circle. In this video, we're going to talk about how when we're given some of those pieces of information or parts, how we can use those pieces to get the whole picture. To do that, we're going to use both of the equations, either one of them or both of them, to find the missing information. Essentially, so remember, this is the equation for arc length. You take the entire circumference or the distance around the circle, and then you multiply it by the fraction of the circle that you want. Using the central angle and, divide that by 360, the whole circle. That tells you what the arc length is of just the part, like just the arc that you're interested in. Over here, you have the area of a sector. You take the area of the entire circle, and then you multiply it by just the sector, or just the central angle divided by 360, which is just the fraction of the circle that you're interested in. So this equation over here gives you the arc length. This gives you the area of a sector. You are going to use either one of these equations or both together to find a piece of information given parts of the information. So let's kind of see how this works. We're going to kind of be detectives. We're going to have some clues, and then we're going to use these clues to figure out what the missing information is. So let's look at example 1. It says a sector of a circle has central angle 135 degrees. So that's a clue. That is a piece of information that we have that we can use. And it has an arc length of 3 pi units. That's another clue or another piece of information that we can use. The question is that we're going to try to solve is what is the radius of the circle? So that's the missing piece of information that we're going to try to find, and we're going to use these clues along with one or both of these equations to help us. Now, because we have the central angle and because we have the arc length, we're probably going to want to use this equation that talks about arc length. So if we plug 3 pi in there, and if we plug 135 in there for the central angle, we can just use this equation to solve for the radius, which is what we want to find. So let's go ahead and do that. So we're going to use this equation, but for arc length, we're going to put 3 pi. So I'm going to say 3 pi equals, and then the central angle divided by 360 gives us the fraction of the circle that we're interested in. So I'm going to say 135 over 360 times 2 pi, and the radius we don't know. That's what we want to try to find. So we're going to use this to try to figure out what the radius is. So we used our 2 clues, we plugged them in, now let's see what we get. So to solve for r, the first thing I'm going to do is I'm going to divide both sides by this 2 pi. So when I do that, the pi's cancel out, the 2's cancel out, and then over here the pi's cancel out. 3 divided by 2 is 1.5, and then equals 135 divided by 360, those both canceled out, times r. So dividing by 2 pi on both sides gave me a little bit simpler equation. Now, because fractions can be kind of tricky when you're working with them, I'm actually just going to change this fraction into a decimal. So when I take 135 and I divide it by 360, I actually just get 0.375r. So now if we want to find out what r is being multiplied by 0.375, we just need to divide both sides by 0.375. So divide by 0.375, divide by 0.375, those cancel out, and you end up with r equal 4. If you do 1.5 divided by 0.375, you get 4. So over here on the right we had r, and that equaled 4. So that means that if the central angle was 135 and the arc length was 3 pi, that means the radius ended up equaling 4. So in this situation, we only actually had to use one of these equations to get the piece of missing information that we were after. Sometimes, however, you're going to have to use both equations, and that's what's going to happen in this next example here. So I'm trying to see both equations up here and this down here. I don't know if we can do that. So looking at this one, it says a circle has radius 12 inches. So that is a piece of information that we have. So let's use that. What is the area of a sector with arc length 8 pi units? So we want to know what is the area of a sector. That's our missing information. These are the two pieces of information that we have. Now, if we want to know what the area of the sector is, we need to use this equation over here, because this is area of a sector equals this. We have the radius to plug in, but we don't have a central angle. However, we can find the central angle using this equation, because we do have an arc length, that's 8 pi, and we do have a radius, that's 12. So you can plug both of those pieces of information in here to find the central angle. Once we have that, we can use the central angle and the radius, which is 12, to find the area. So this is a situation where we have to use both of the equations together to get the piece of information that we want to try to find. So that's what we're going to do. First, we're going to use arc length. We know the arc length is 8 pi and the radius is 12. So I am going to write my equation like this. Arc length is 8 pi, so we have 8 pi equals the radius. We don't have the central angle, so I'm going to leave that over 360 times 2 pi 12. Okay, so I plugged in the arc length, I plugged in the radius, now I'm just going to find the central angle. So to do that, I'm going to divide both sides by 24 pi, because 2 times 12 is really just 24. So over on this side, all that cancels out. Over here, we end up with 1/3 pi, because 8, and the pi's cancel out too. So because 8 divided by 24 is just 1/3. So the pi's all cancel out, so that's gone. We just have 1/3 equals that over 360. Now we're trying to find the central angle. Right now it's divided by 360, so to undo divided by, we multiply. So we're going to multiply both sides by 360. Oops. Over here it cancels out. We just have that. This really turns into 360 over 3, because when you're multiplying fractions, you multiply straight across. So 360 times 1 is 360. 1 times 3 is 3. 360 divided by 3 is really just 120. So we use the first equation to find the central angle. Now we have the central angle. We can use that to find the area of the sector. That was our original goal, is to find the area of a sector. And now that we have the central angle, we can use that along with the radius of 12 to find the area of the sector. So let's do that. The area of the sector equals the central angle, which we said was 120 over 360, times pi r, we know r, that's 12, so 1 times, let me start over, pi times 12 squared. So the area of the sector, now we're just going to simplify this and see what we end up with. We have 120 over 360 times pi 12 squared is 144. I'm going to say 120 times 144, because that's also like on the top of a fraction, over 360 times pi. when I do that, when I do 120 divided by 144 and then divide it by 360, I get that the area of the sector equals 48 pi. We could leave it just like that. That's the most accurate answer. Or we could do 48 times 3.1415 and actually see what that is just a number. So, or if you do that, 48 multiplied by pi gives you 151.3 rounded inches squared. So in this situation, we actually had to use both equations to get our ultimate answer. We had to use the first equation to find the central angle. And then once we had the central angle, we could plug that in over here along with the radius to get the ultimate area of the sector. So these are kind of fun. They're kind of like puzzles or riddles. You have to see what clues you have, and then you have to use those clues to plug it into the different equations and use them to get the ultimate piece of information that you want. Go ahead and try the practice. I would look at this to help you. It's probably going to be a big help as you're doing the practice, and see how you do. If you have any questions, you can always email me or come to one of the meetings and I can answer your questions there. Thanks so much. Bye.